Yes, sir. 1, 2, 3, 4, 5, 6, 7, 8 girls and 6 boys. 14 are present. Still some are absent. And it will daytime they will come. Right? No, no. And that's why I'm just kept on nearby, right? Okay. We have already started chapter atomic structure and chemical bonding, right? And we completed some headings like valency, valence shell, soft shell, ion, cation, anion. And today, onwards, there is presentation from students, and first presentation will be done by Krijal, Khadka, right? So she is going to present about chemical bonding. Then she will be explaining about mainly electrovalent bond. What is electrovalent bond and how it is formed, and some examples of the compounds which are formed by electrovalent bond. Then electrovalent compound, electrovalency, and characteristics of electrovalent compounds. Right? So without wasting time, let's welcome on the stage Krijal, Khadka. To find out only first for some time, okay?
So, namaskar everyone. Good morning to respected our science teacher and my dear friends. So, after a long time, I am here, Krijal Khadka, presenting about the chapter 14, and the chapter name is Chemical Bonding and Atomic Structures. And the first portion I got was chemical bonding. The force of attraction by which atoms or a group of atoms are combined together to form a stable chemical molecule or compound is called chemical bonding. So chemical bonding is the process in which group of atoms or one atom is combined with another to form any kind of chemical molecule or chemical compound. And types of chemical bond. There are typically 3 types of chemical bonds. One is electrovalent or ionic bond, and next is covalent bond and coordinate bond. So in my turn today I am going to explain about electrovalent bond. So electrovalent bond is formed when 2 atoms in which one atom belongs to a metal while the other belongs to a non-metal. In electrovalent bond, one atom belongs to metal while another belongs to non-metal, and the chemical bond is formed by the transfer of electrons from the valence shell of one atom to the valence shell of another atom, and this is called electrovalent bond or ionic bond. So here the electron of one valence shell is transferred to another valence shell, and this process is called ionic bond or electrovalent bond, and its valency is called electrovalency. And the compounds which are formed as a result of electrovalent bonding are called electrovalent compounds or ionic compounds. So the compounds which are formed after the process of electrovalent bonding, it is called ionic compounds and electrovalent compounds. And some examples of these electrovalent bonds, their compounds are, one is sodium chloride, it's NaCl, and it is an electrovalent compound which is formed only when sodium reacts with chlorine. When sodium reacts with chlorine, the sodium chloride is formed. The electronic configuration of sodium is 2, 8 and 1, whereas the chlorine electronic configuration is 2, 8, 7, and this figure shows the process of electrovalent bonding between the sodium and the chloride. And next is magnesium chloride. That must be here. And the electronic configuration of magnesium and chlorine are 282 and 287 respectively. So this figure shows the process how the magnesium chloride is formed. And next is potassium oxide. The electronic configuration of potassium is 2881 and oxygen is 26. and oxygen have a ionic bonding. And next, this is the last portion of my slide, and this is all about characteristics of electrovalent compounds. And the electro compounds have high boiling and melting points on account of the strong inter-ionic force of attraction. This point says that they have high melting and boiling point. And second point is they are found in the solid state and very brittle. They are found in solid state, not in gas or liquid state. And in molten or aqueous solution, they conduct electricity. And if they are in the form of melted form, if they are in a state of melted form, then they can conduct electricity. That means electricity can be passed if they are in melted form. They are soluble in water but insoluble in organic solvents. That means they can dissolve easily in the water, but they cannot be dissolved in organic solvents. And they contain metal in their molecule, and their molecule contain metal. Now, by saying this much, I like to end my presentation.
Thank you. So, as usual, Krijal gave very dashing presentation, right? In next bell, I think there is presentation from Star. So what do we do? First of all, we will complete this routine presentation. Then those who are present today, they will get their presentation in next class. Understood, right? Everybody must think, check how they have done last time and how is present presentation. Understood or not? Everybody is capable, so everybody must give the outstanding performance. Okay? So children, now let's discuss first of all metals and non-metals. Okay? Could you remember the first 20 elements? First 20. What are they? Okay, first look at here. Right? Hydrogen, then helium, then lithium, beryllium. Okay, so let me write this a bit differently, then it will be easy. Actually, I am going to tell you about these metals and non-metals, then where electrovalent bond takes place and where covalent bond takes place. You have to make your concept clear. Hydrogen, helium, then I am writing here lithium. Lithium this side. Here, after lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium. I am just separating metals and non-metals. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. Okay, so then. Out of first 20 elements, I have made two groups. This is the group of non-metal. Which are the non-metals in top 20 elements? Hydrogen, helium, carbon, nitrogen, oxygen, fluorine, neon, silicon, phosphorus, sulfur, chlorine and argon. And in these three, argon, neon and helium, these are inert. These are passive. They do not take part in chemical reaction. But their valence is zero. Valence is zero means they neither gain electron nor donate electron nor share electron. Really passive. They are Kumbhakarna elements. Kumbhakarna we have watched in some cartoon characters also, in movies also, right? Very big figure, eating only once in a day, in a year, and sleeping whole means rest of the time, right? That is also just imaginary character. Actually, who can survive like that? It's not possible, right? We are the students of science, so we don't believe on it. Okay, children, and these are metals. So which are the metals? Tell me. Which are the metals? Lithium, beryllium, boron, carbon, magnesium, aluminium, potassium, calcium. So, if there is bond between calcium and silicon, metal and non-metal, that is electrovalent bond. If there is bond between sodium and nitrogen, electrovalent bond. First metal, second non-metal. Such type of bond is called, what do you call it? Electrovalent bond. In electrovalent bond, there are two elements. First element is metal, second element is non-metal. Make your concept clear. Right? First is metal, second is non-metal. Then first metal element donates electron. What does it do? One donates electron. Non-metal, what does it do? Receives or gains electron. That means in electrovalent bond, transfer of electron takes place. One gives, another takes. For example, you identify what is this? 11 proton, 12 neutron. Which element is this?
Sodium.
Sodium. Okay, just pay attention. 2, 3, 4, 6, 7, 8. What is this? Sodium atom. Make your concept clear. Eh? Sodium atom. I will teach this in two ways. Which one you feel easier, you do accordingly. Okay. Sodium atom plus 17 proton, 18 neutron. What is it?
Silicons.
Chlorine. What is that? Chlorine. In first orbit, how many electrons are there? 2. In second, how many? 1, 2, 3, 5, 6, 7, 8. In third, how many are there? 1, 2, 4, 5, 6, 7. We discussed already about octet. Octet means presence of how many electrons in the outermost cell? 8 electrons. If there are 8 electrons in the outermost cell, it is stable. It does not take part in chemical reaction. Now, if you talk about sodium, is it in octet?
No.
Please pay attention. Is it in octet?
No.
There is only one electron. No, that's why it is not in octet. Chlorine, is it in octet? How many electrons are there in the outermost orbit? 7. It is also not in an octet. Then, if it gives one electron to which one? Chlorine, then this will be left. Then how many electrons will be there?
8.
8. Will it be in octet state or not?
Yes.
In the same way, when one electron is donated to it, then also there will be 8 electrons. Will it be in octet or not? When it is in octet, it is stable. Then what will happen in next state? Next, let me draw here. It will be like this. 11 proton. How many neutron? 12 neutron. In first orbit, how many? I am talking about sodium. 2. Second, how many? 1, 2, 3, 4, 5, 6, 7, 8. Now last is missing. There is no last orbit. Do you know why no last orbit? One electron is donated or not?
Yes.
Finished. So it is called Na plus. What is it called? Why is it called Na plus? Here are 11 positive charges. How many negative charges?
8.
10 negative charges. 11 minus 10?
1.
1. So 1 electron, right? Now another. Chlorine has got one more electron or not?
Yes.
Then 17 proton, 18 neutron. First how many? 4, 5, 6, 7, 8. Second, first there should be only 2. 1, 2. Third also 1, 2, 3, 4, 6, 7, 8. Now what is it? This is Na plus, this is Cl minus. Why Cl minus? It has gained one electron. So this is NaCl. NaCl molecule. So sodium loses one electron, chlorine gains one electron. If so, one molecule is formed. What is the molecule? Sodium chloride. Now let's see the slides. How to define chemical bonding? What is chemical bond? What is the definition? Say here. force of attraction by which atoms or group of atoms are combined together to form a stable chemical molecule. If I write here O2, what is this? What is O2? Molecule of oxygen. How many atoms are there? So, two molecules of oxygen are linked together with the help of what? Force of attraction. That force of attraction is called chemical bond. Two or more atoms are linked together with the help of a force of attraction. That force of attraction is called chemical bond. So the force of attraction is created by two ways. By transfer of electrons, electrons move from one valence cell to another cell, or sharing of electrons. If I give one electron to, suppose I am an atom, Krijal is another atom, one electron is given to her, means that is transfer of electron. But if we share same electron, then that is sharing. By transfer or by sharing, force of attraction is created. What is done here? Electrons are shared or transferred? Same electrons are shared by nitrogen and hydrogen. Nitrogen and hydrogen. Are they shared or not?
Yes.
So, by sharing also, force of attraction is created. See, one electron of hydrogen and one electron of nitrogen are shared. Here also, one electron of nitrogen, one electron of hydrogen are shared. Right? By sharing, force of attraction is created. That is called chemical bond. Like, what is this? What is the name of this compound? Carbon dioxide. How many atoms are here? 3 atoms are here. Also, means one carbon, oxygen. See? Are they linked like this?
Yes.
NaCl. NaNCl. So Na plus Cl,
Minus.
it loses electron, it gains electron. Okay. How many types of chemical bonding are there? How many types? 3 types. What are they? Electrovalent bond or ionic bond. Second one, covalent bond. Third one, coordinate bond. So in class 9, we are not going to discuss coordinate bond. We will discuss only electrovalent bond or covalent bond. How electrovalent bond is created, how covalent bond is created, we will be discussing in this class. Now, first of all, what is electrovalent bond? What is the definition? The chemical bond, pay attention here, eh? The chemical bond that is formed by transfer of electrons, that is formed by transfer of electrons from metal atom to non-metal atom, from metal atom to non-metal atom. That is called electrovalent bond. Another heading is there, electrovalency. What is here? How many electrons are transferred or how many electrons are gained? That number of electrons which are transferred is called electrovalency. For example, if sodium gives 1 electron, then what is the electrovalency of sodium? 1. If calcium donates 2 electrons, then what is the electrovalency? 2. If oxygen gains 2 electrons, then what is the electrovalency? 2. If aluminium loses 3 electrons, then what is the electrovalency? 3. How many electrons are transferred? Moved from one to another, that is called electrovalency. Especially, valency of element is the electrovalency or covalency. Okay? Covalency we will be discussing next one. Next one, electrovalent compound. What do you mean by electrovalent compound? Those those compounds which are formed by electrovalent bond. Compounds which are formed by electrovalent bond are called electrovalent compounds. In electrovalent compound, first element is atom, second element is first element is metal, second element is non-metal. Like whatever things Na, is it metal or non-metal? Earlier I just gave the chart.
Metal.
This is metal, Na. And oxygen, metal or non-metal? If so, it is electrovalent bond. Once again, let's remember which are metal and non-metal. I write here metal and non-metal. Okay, can you give the example of metal? One is lithium, beryllium, boron, sodium, magnesium, aluminium. Look at here, first one the element. So lithium, beryllium, boron, sodium, magnesium, aluminium, and potassium and calcium. Only these are metals. Rest of others like hydrogen, carbon, nitrogen, oxygen, fluorine, silicon, phosphorus, sulfur, chlorine, these are non-metals. So you have to check whether first one is metal or non-metal. In the molecule, if I write here O2, O2 is also molecule, right? So is there electrovalent bond? Oxygen is metal or non-metal?
Non-metal.
Non-metal means there is no electrovalent bond. Okay. If I write here K, Cl, okay. Potassium chloride is here, right? So potassium chloride, is it metal or non-metal? Sorry, electrovalent bond or not?
Not.
Potassium is metal or not?
Yes.
If first one is metal, then electrovalent bond. If first one is metal, then isn't it electrovalent bond? Yes, sir. First one you have to check. Like CO2, is there electrovalent bond? Carbon is metal or non-metal? If non-metal, then there is no electrovalent bond. MgO, is there electrovalent bond?
Yes.
How?
Engine.
Magnesium is metal. If first element is metal, then that is electrovalent bond, otherwise not. So, here are some characteristics of electrovalent compounds we have to see. How many characteristics are given? 5. What's the first characteristic? They have high boiling and melting point. Boiling point means they change into gas at very high temperature. Melting point means they change into liquid at high temperature. Boiling point is high, melting point is high. And mainly they are found in which state? Solid state. And they are brittle. What is by brittle? They can break easily. Brittle means break easily. And they can conduct electricity either in aqueous solution. Aqueous means dissolved in water, or molten in liquid form. When you heat sugar, slowly it changes into liquid form, that is molten state. But sugar cannot conduct electricity because it is not made up of electrovalent bond. Because in sugar, what is the molecular structure of sugar? C12H22O11. Either metal atom, so there is no electrovalent bond, so it cannot conduct electricity. They are soluble in water. They can dissolve in water, but they cannot dissolve in organic solvent. Organic solvent means petrol, kerosene, mobile, ether, etc. And next is they contain metal in their molecule. One metal. Like NaCl, why not? NaCl, CuSO4. Copper is metal. Yes, sir. Like AgNO3. Ag is metal. So first atom, if it is metal, then it can conduct. Third can conduct electricity in aqueous solution. Aqueous means dissolved in water or molten state.
That means ocean water can be used for electricity.
Ocean water can be used for conducting electricity. Why not? If electricity is supplied in ocean water, many animals they can die. Last time I had gone to visit ocean, Indian Ocean, Arabic Ocean, Ganga Sagar, right? I tasted the water. It was salty.
Very salty or
Yeah, why not? Too much salty. Some water went inside also, and so I suffered from woke up a long time because it was polluted water, right? Okay. Here are some examples of electrovalent compounds. So she has brought here 2, 3. One easy method I will teach you. Okay.
So then from normal water we cannot produce.
Normal water means actually the water which we cannot produce means we cannot conduct.
Yeah, electricity.
No, from either normal water or seawater we can produce electricity. Production is different, but conduction is different. So salty water is good conductor of electricity because it breaks down into ions like Cl. If there is presence of NaCl, what is that? If there is presence of NaCl, when electricity is supplied, then it changes into Na plus and Cl minus. Sodium ion, chloride ion. When there is ion, electricity can pass easily. Cation, Na plus is cation, Cl minus is Ni. Okay? Now, children, look at here. Easy method I will teach you of this electrovalent bond. Sodium. Sodium, what do you write here? Na. Right? In Na, there is 1 electron. At last, how many electrons are there? 1. Plus Cl, how many electrons are there? 1, 2, 3, 4, 5, 6, 7. Easy method, right? Either you just draw the atomic structure or you can do like this also. Now, this 1 electron is given to it. It becomes Na plus. Then Cl, how many electrons will be there? 2, 4, 6, 1 from here. This is transfer. This is transfer. This is electrovalent bond. What is this? 1 electron is transferred or not in this way. Okay? So this is all about electrovalent bonding. So open your book once and read this portion once again. Chemical bonding, types of chemical bond, and this electrovalent bond, electrovalency, and some examples like what are the examples? Sodium chloride. Next one is here, magnesium chloride. Magnesium chloride, how is it formed? Say here, magnesium donates 1 electron to chlorine, another to chlorine. And next one is potassium oxide. 1 potassium, 2 oxygen. And this portion will be over. Okay, will you do that one now? And your next duty is note making. Is that clear? But next thing, remember, don't forget to draw those molecular structure of the chemical compound. Clear? Okay, thank you.